Hi everybody, thank you for joining us in this session. My name is Nicola Camillo and I'm an IT manager at Venoto Banca, that is one of the most important banks in Italy. And today, together with my colleague Alberto, we want to talk about a solution, a graph-based tool to govern an IT infrastructure and architecture. Thinking, deploying and implementing an IT infrastructure and architecture from the scratch is a challenging opportunity. For the last couple of years, we've been working, being involved in this project, in this huge project at Veneto Banca. Our IT operation, our COO, give us the mission to completely modify the information system technology of the bank. We want to adopt, so we thought about how to do it. We want to adopt the microservices paradigm exposed by Martin Fowler. And we built a multi-channel architecture that was a platform that enables the core applications of the bank, the brand new core application of the bank, to run in production. This architecture, on this architecture rely both applications in the supervised channel, that is to say the tools that our colleague in the branch of the bank uses, like the workstation, the contact center, and the personal financial planning, and also for the self-channel application, mobile banking, internet banking, and so on. At the end of our work, we discovered that the landscape of our service was made by almost 300 business services that compose the business service layer, and that orchestrated about 600 of atomic service that compose this atomic service layer. Each of them exposing a particular function or functionality. Okay, but what you may think that this startup project was very hard to put in production. At some time, we faced with this problem because you may know that a tool such what we have done is not considered as a useful or a brand new deliverable inside the project. So our IT director said, we can do it later. But then we faced with this problem at some time. It was the problem of documentation and governance. We can't answer a question like, can you describe your multi-channel architecture in terms of layer services? Right now, we have to go to our sheets, go to the code, and then put them on an Excel file to answer this question. We have problems with the impact analysis. What does it mean if a service provider or a service become unreachable, and what this mean for your platform? What are the problems? And then we have a problem in automatic feature activation. That is to say, we want to change the service behavior on the fly without deploying again and again it. So we put our ideas in several meetings, brainstorming. At the moment, we didn't know anything about graph databases and Neo4j. But we knew that we need a repository to collect the informations and not an Excel file. We need a tool that rely on relationship because we thought and we think that in relationship stands the meaningful information for our system and for all the ET system. And the tool has to be whiteboard friendly. So we have not expertise in SQL or ER programming. So we want to draw the data model, and then this drawing has to become the physical representation of our needs. As I say, previously, the first approach was very primitive. We collect this information. We had in mind the data model that has to be, but we collect the information in an Excel file, and we made this kind of process after the deploy of the application in production. So the problems, okay, it's very time consuming, it's error prone because we can make a mistake, and the information were not up to date with the software changes. So we move forward and we have these two approaches. The first one was based on a relational database because our team have the expertise we needed, and we want to cut straight to the point. So we use the relational database to store the information of the service catalog. So we build the parsers and the readers of our source code, along with the adapters for building the data model according to the data schema of the relational database. But then something happens. We thought that relational database, I ought to say, is useful for relationship, but this is not true. We discovered that this is not true. We have problem in writing the SQL queries we needed to extract the meaningful information from our system. We have problem to explain these queries to our IT people, most of all to the business ones that help us to design the applications. And the relationship had lost their meanings. Are not relationship, but only pair of key and foreign key in the database. Then finally, thanks to Larus and to Lorenzo Speranzoni, that is a Neo4j evangelist in Italy, we discovered the power of graph databases and of Neo4j in particular. It was we were very impressed how Neo4j treats the relationship. They become first-class citizens in our data model. So me and Alberto could sit and draw a graph without pain. If we made a mistake in the first release of the data model, we can change it, rechange it without changing the adapters or the parser of our source code. Okay, the pro and cons, I keep on going. So we built our service catalog, that is the core part of this tool, this magical tool that could answer all the questions only simple by pressing a do it button. Okay, it's a dream, but you may think that this service catalog could help us to automate some step of the process. And if we put the service catalog in the middle of our system, we can then use it for not only for impact analysis, but also for the hot configuration of the services, the switch on-off of the features, and for reporting the sanity check of our system to our stakeholder in order to bring them up to date to the modification or the health of the system. Now I give the word to Alberto that could explain better than me why Neo4j was the right choice for us.
Hi everybody. I want to give you some key features, some valuable features about Neo4j. We think that graphs are the most natural way to represent entities, nodes, that have connections. Another important feature is that we can add easily new types of nodes and relationships, so the model can evolve in a simple way. So when we have to refactor the data model, there is no nightmare or pain. Another important feature is that the whiteboard model is the physical model. So what we draw on a paper sheet is what we get on a database, and is what we can see on the web console. So it's easy to get a view, an overall view of our components, software components, and it's also easy to explain to other people with no technical backgrounds. Another feature is within that most of the information for us rely on relationships. So it's very important to get this more of the information from the repository. Other available features are it's easy to integrate, expressive and powerful query language, is written on top of JVM. Our system are Java-based, so this is a good thing for us, and so on. So I want to describe in more detail our data model. So we started to draw our model on a paper sheet, and we started from the bottom. Our atomic services depends on many data providers, and the data providers provide us many services that we call external resources. For example, web services, or maybe queries on a database. Our atomic services are the building blocks for our business services that are in turn the services consumed by our applications. So the process was a layer by layer design of our data model, and it was a successive refinement. So for us was very important the easy way to rethink the model and change it. So Neo4j was and is a good thing when reviewing your data model. We use Spring Data Neo4j to map our entity classes. So Spring is a framework that we know very well. So to be more productive and very fast, and to go fast towards production, we choose Spring Data Neo4j. I want to show you two brief examples of what we have done with our service catalog. So the first one is the software changes. So we have a change sets, software changes. These are our starting point in the graph. And then we go up. So we do a bottom-up analysis, and we can collect all the impacted components. In general, these are applications or maybe business services. And then we can extract all the test plans, test suite, and test cases that we have to run. And eventually, we can notify to the change advisory board what are the impacted components. One of the key feature here is that we don't need to run all the test suites or test cases, because we can extract a subset of those plans because we have a link between the impacted components and the test cases. A similar example is an impact analysis. It's like a business continuity example. We have an external provider or some external service that doesn't work, and we want to know what are the services that are impacted, and we want to alert or warn someone and the users of the applications. So we can say that you must have a service catalog inside an IT governance process, or at least for us, it's very important. It's useful if you want to complete and have an up-to-date application map. We can do a snapshot of our service catalog on demand, or we can attach this to the continuous delivery process. Once you got it, you can extend the graph with more heterogeneous information, so areas of interest. For example, the infrastructure topology. So we can do business continuity impact analysis. And for us, we can say that implementing an IT government tool based on Neo4j has been the right choice, and it's the right choice. Because the relational databases do not manage relationships in a strict manner for us, and Neo4j does it. It's whiteboard friendly, so it's very easy to understand and to use and to draw your model. It's powerful and easy, and it's powerful because it's easy. Cypher is a very powerful query language, and last but not least, we like it. So these are future evolution. So business continuity here, enterprise application architecture map, because we can extend our data model. So
stay tuned.
It's very simple to extend the model, and even for cost management, because if you want to do some evolutions on our applications, we have to know what are the services that will be impacted on it, so we can use it for this. I hope you enjoy our talk. I want to thank you, and I want to thank you, our beloved family, for support and patience. And I want to thank you, Lorenzo Speranzoni, and Neo4j for the great opportunity. Thank you, everybody.
Thank you very much.